Welcome back to Physics with Miyoshi. I want to talk to you today about kinematics of falling objects, and I want to let you know that it's not that much different than any other things we've done so far with objects in one dimension. The different thing about falling objects is simply that our acceleration is constant like before, and that constant acceleration we know to be gravity, which in the international units is 9.8 meters per second squared. Okay, now for this problem here I'm going to approximate it a little bit, but I just want to give you a quick example of how to find a final velocity when we know an initial velocity of 0 if we've dropped a falling object. So what I'm going to do is just basically drop something at 0 and it's going to fall down, and we want to know what the final is after 3 seconds, which that took less than 3 seconds, but that's what we want to find. Okay? So how do we do that? Well, we're going to come back to one of our original equations and look at it. Acceleration, the average acceleration, is delta v over delta t. And we remember that delta t is, well, maybe we don't know this yet, but delta v is our final velocity, or final speed in this case, minus the initial speed, or the initial velocity. So if we rearrange this equation or put that in there, now we have A average is Vf minus Vi, and then we have delta t is the same, so it's going to be time final minus time initial. And if we consider the initial time to be 0, we can just say that that's t final, and in reality we can just say that is our t. So I'll change that. I'll also change that A average to just be A, because we know that for our scenarios right now that we're using are constant. We have a constant acceleration. So I'll just change that to A. So now we know that A, so we'll put that as a t. So A is V final minus V initial divided by t. So we want to find out what the final velocity is, so we can rearrange this equation. I'll move the t over by multiplying by t, and then I get AT is V final minus V initial. Okay? And then I can move the V initial to the other side, and then we have V final is V initial. Well, we'll add V initial so we can stay consistent. And then it's supposed to be a V initial plus A times t. Now, many people will get rid of the final there, but I like to leave it there. But we have V final is V initial plus AT, which we see is one of our beautiful constant acceleration equations. And when the V initial is 0, then we can just say V final is A times t. In this case, our acceleration is gravity, so we can just say that's g times t. And if we approximate 9.8 as 10, we can say that our final speed when I drop something for 3 seconds should be around 30 meters per second. And we can see that here. Let's just approximate that as 10 meters per second squared times 3 seconds. That would give us 30 meters over second, because one of our seconds goes away. Okay? So this is one nice way to find out how to do constant acceleration for a falling object when we know that the initial velocity is 0. You could use the same exact equation right here when that initial velocity is not 0. So, and we'll talk about that, and we'll do some more equations like that, or we'll do some more problems like that, and we'll learn how to use some of these other equations for falling objects in later lessons. So, join again. Thanks again for joining, and hope you come back for more Physics with Miyoshi.